we now discuss the solution of a problem from the section Differential Calculus. The problem is related to the differentiability of a given piecewise function. This question has appeared in the Joint Entrance Examination Main held on 29th June 2022 in the first shift. The given question is, let f be a function from the set of real numbers into itself defined by f of x is equal to, it is defined like this, as a piecewise function. Agreed? Now, where this bracket t is the greatest integer less than or equal to t. Let m be the number of points where f is not differentiable and I is the definite integral given by integral minus 2 to plus 2 f of x dx. Then the ordered pair m comma I is equal to, we are given four options, option A, option B, option C, option D. We are given a real valued function defined on the set of real numbers defined like this as a piecewise function. And it is given m is the number of points where f is not differentiable and I is the definite integral given by integral minus 2 to plus 2 fx dx. Required to find the ordered pair m comma I. We now discuss the solution of the problem in detail. We have this function fx. This is a piecewise function. Agreed. First, we take this first part. This is the first branch of the curve f of x. Maximum t less than or equal to x, t cube minus 3t when x less than or equal to minus 2. That means in the interval minus infinity to minus x less than or equal to minus infinity to 2, the function is defined like this. So let's first of all attack this, and what it is we will decide now. Let g of t is equal to t cube minus 3t. Because we are talking about the maximum, so let's take its derivative. That is g prime t is equal to 3t square minus 3 and equate it to 0 to get the critical points. We get the critical points, t is equal to plus or minus 1 are the critical points of this g of t. Now take its second derivative, that is 3t, and this is negative when t is minus 1 and this is positive when t is equal to 1. So the maximum is attained for g of t at t is equal to minus 1. And what is the maximum value? G max is equal to the value of g at minus 1. And in g of t, substitute minus 1, you get 2. So the g max is true. Now take this g of t, that is the maximum t less than or equal to x g of t when x less than or equal to 2 will be equal to g of x, the same function, up to minus 1, x less than minus 1. At minus 1, it attains its maximum, that is g max, and we say that in this interval minus 1 less than or equal to x less than or equal to 2, in that the g max will be there, because this is the maximum t less than or equal to x as x is moving in this. So in this interval, how this is g max? How this is g max? Now take its g prime t. Take its g prime t, and take any point in this interval minus 1 to 2. So let us say 0. So you will get, if you substitute here, you will get minus 3, which is negative. That means in this interval, this g of t is a decreasing function. decreasing function. And it is defined as the maximum of g of t less than or equal to x. That means x is moving in this. As x is moving in this, it takes only g max. So in this interval, it is only g max. And that is x cube minus 3x when x less than minus 1, and it is 2. That is the maximum. Minus 1 less than or equal to x less than or equal to 2. So that is the first branch of the function f of x. Okay. There is another branch which is typical here, that is bracket x minus 3 plus 9. So let h of x is equal to bracket of x minus 3 plus 9 when 3 less than or equal to x less than or equal to 5. Because it's a bracket function, take what is its how this behaves in the intervals, that is minus 3 less than or equal to x less than 4, 4 less than or equal to x less than 5, and you have to consider like that. So 3 less than or equal to x less than 4, and 4 less than or equal to x less than 5, and x is equal to 5. X is equal to 5 because in this 5 is included. So in that these functions you have to compute. So in this interval 3 less than or equal to x less than 4, mod of x minus 3 is 0. And in this interval 4 less than or equal to x less than 5, the mod of x minus 3 is 1. And in this, and at x is equal to 5, this is mod of the bracket function. I'm sorry, I have to say bracket of x minus 3, bracket of x minus 3. So this will be like this, and that is given as 9 when h of x is 9 when 3 less than or equal to x less than 4, it is 10 when 4 less than or equal to x less than 5, it's 11 when x is equal to 5. So this branch is broken into again this piecewise function. So incorporate these two things, that is the first part, and the third part you incorporate in this f of x, and this will be, we will get f of x as this one, right? The blue one is that maximum function, and these red ones are that bracket function. Agreed. Now this is defined as a piecewise function, and this function, and who are the elements? The members are all polynomials, and every polynomial is continuous everywhere, and because they are in the branches, this is a piecewise continuous function, except possibly at these transition points, the changeover points, that is at minus 1, at 2, at 3, at 4, at 5. So it's continuous everywhere except possibly at these points. So we'll now check the continuity of f of x at x is equal to minus 1, 2, 3, 4, 5. Now here we are computing the left hand limit of f of x at minus 1. So that will be limit extends to minus 1 on the left of it. So x minus 1 to, say x is moving to minus 1 from left, and the function is x cube minus 3x, and the limit extends to minus 1. Compute, and you will get 2. And minus 1 plus, it is 2. So the left hand limit is equal to the right hand limit, therefore it is continuous. It is continuous at x is equal to minus 1. And similarly, f of x is continuous at x is equal to 2 and 3. Right. We move to the 4. Limit extends to 4 minus. That means the left hand limit of the function fx at 4. So the left hand is moving to 4. Left will be 9. And right will be 10. They are not equal. Therefore, continuity is lost. F of x is discontinuous at x is equal to 4. By the similar argument, it is also discontinuous at x is equal to 5. So, f of x is discontinuous at x is equal to 4 and x is equal to 5. Suppose at 4 and 5 it is differentiable. Differentiability always implies continuity. So differentiable at x is equal to 4 will imply it is continuous at x is equal to 4, which is a contradiction because it is discontinuous at x is equal to 4. Therefore, it is not differentiable at x is equal to 4. Similarly, it's not discontinuous. It's not differentiable. It's not differentiable at x is equal to 5. Therefore, f of x is not differentiable at x is equal to 4 and 5. And our concern is to talk about the number of points where the function f of x is not differentiable. Now, continuity is attained at x is equal to -1, 2 and 3. It is possible. It is possible. It may be differentiable at all these points or differentiable at some points and not differentiable at some other points. Let's see, discuss that in the next slide. Right. We have f of x is not differentiable at x is equal to 4 and x is equal to 5. And we have f of x is continuous at x is equal to -1, 2, 3. So let's see the differentiability at -1. Now we check the differentiability at x is equal to -1, 2 and 3. And the left hand derivative we are computing at -1. And that is given by limit h tends to 0 f of -1 minus h minus f of -1 by h. Remember, you are computing the left-hand derivative of the function f at -1. So, f of -1 minus h is substitute for x -1 minus h, and f of -1, so substitute my x is equal to -1 in this. So, simplify, you will get limit h tends to 0 of -h minus h square, and that is 0. And what about the derivative or right hand derivative? The right hand derivative is 2. When you differentiate it will be 0. And they are equal. They are equal. That means it is differentiable. Therefore, f of x is differentiable at x is equal to -1. Now at 2, we first chosen to talk about the right hand derivative. The right hand derivative is f of 2 plus h minus f of 2 by h as limit h tends to 0. F of 2 plus h means in this you substitute for x 2 plus h minus f of 2 by h. Simplify, you will get limit h tends to 0 of 6 plus h, and when you take the limit it is 6. It's not 0. It's not 0. I'm sorry. It is not 0. It is not 0. It is 6. Please note down it is 6, and f prime of 2 plus will be here, and the derivative is 0, and they are not equal. Here it is not 0, it is 6. It is 6. So therefore f of x is not differentiable at x is equal to 2, and similarly f of x is not differentiable at x is equal to 3. Agreed. We take it and we continue in the next slide. So what is that we have? We have f of x is not differentiable at x is equal to 2, 3, 4, 5. Therefore, m, the number of points at which f of x is not differentiable is 4. 1, 2, 3, 4. 4. Now, we have to compute I. I is given as -2 to +2 of f of x. And -2 to -1, the function is different. And -1 to 2, the function is different. Therefore, break it. Break it. So, continuity is also there, no problems. So, break it. So, that will be equal to integral -2 to -1. In that, it is the function is x cube minus 3x. Integrate with respect to x. And -1 to 2, in this, the function is 2 dx. And when you integrate, it will be x to the power of 4 by 4 minus 3x square by 2 to be evaluated between the limits x is equal to -2 to -1. And after integration here, it will be 2x to be evaluated between x is equal to -1 to 2. So -1 upper limit, upper limit is -1, substitute. This is -1 substitution minus the lower, that is for at x is equal to minus 2, this is the second bracket, plus 2 is common into for upper it is 2, for the lower minus of minus 1, and simplify and you will get 27 by 4. Therefore, the ordered pair m comma I is equal to 4 comma 27 by 4. Let's look at our options. Our answer is appearing against option C. Therefore, the answer to this question is option C. So that is the detailed discussion of the solution of the problem from the section differential calculus, and the problem is related to the differentiability. It is definitely a difficult question because it takes long time. So it is difficult in the examination hall. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.